journey of maths with Sarah, a true lover of maths. I am back with one more video on the topic domain of real functions. This is part 3. Before watching this video, please watch part 1 and part 2. Let us discuss some more questions related to this. Now consider the question, find the domain of f of x is equal to root over x minus 2 upon 3 minus x. Now, it's a square root function. So, we know the expression inside the square root must be greater than or equal to 0. X minus 2 upon 3 minus x greater than or equal to 0. For our convenience, we are multiplying numerator and denominator by the denominator. Therefore, x minus 2 into 3 minus x divided by 3 minus x the whole square is greater than or equal to 0. We are multiplying numerator and denominator by a positive quantity. So, it is greater than or equal to 0. Now, the denominator is a perfect square. Therefore, it is greater than or equal to 0. Therefore, x minus 2 into 3 minus x is greater than or equal to 0. We have to find out the region where it is positive. So, it is minus infinity, plus infinity, x is equal to 2 and x is equal to 3. The whole region is divided into 3 parts. We have to find out the region where it is positive. Put the value of x as 0. Put the value of x as 0. This is negative. This is positive. So it is a negative quantity. Where is x is equal to 0? Here it is negative. Between 2 and 3 we can take 2.5. Take x is equal to 2.5. This becomes positive. 0.5, that means this becomes positive, and here also it is positive. Here also it is positive. Okay, positive into positive is positive. So here it is positive, and take 3.5 or x is equal to 4. X is equal to 4, this is positive, but here it is negative. Altogether it is a negative quantity. So here it is negative. So what can we say? X is an element of 2 to 3, closed interval 2 to 3. Now look at the function carefully. Inside the square root it is a rational function. Inside the square root it is a rational function. Therefore 3 minus x cannot be equal to 0. What happened to the function if 3 minus x is equal to 0? F of x becomes infinity. Therefore 3 minus x cannot be equal to 0 or x cannot be equal to 3. So what is the domain? Therefore domain of the function is 2 to open interval 3. Don't include 3. Therefore domain of the function is 2 to 3. One more question of the same type. Find the domain of the function f of x is equal to root over x by 1 minus x. Find the domain of the function root over x by 1 minus x. First step, since it is a square root function, x by 1 minus x greater than or equal to 0. For our convenience, we are multiplying numerator and denominator by the denominator. X into 1 minus x divided by 1 minus x the whole square is greater than or equal to 0. Since we are multiplying numerator and denominator by a positive quantity, it will not affect the inequality. Now, since the denominator is a perfect square, it is always greater than or equal to 0. Therefore, x into 1 minus x greater than or equal to 0. We have to find out the region where it is positive. So, draw the line minus infinity to plus infinity. X is equal to 0 and x is equal to 1 are the points. Now, we have to find out the region where it is positive. Take x as minus 2. Take x as minus 2, this is negative and this is positive. So, it is altogether it is negative. Now, between 0 and 1, take x as 0.5. X is 0.5 which is positive. 1 minus 0.5 again positive, means it is a positive quantity. F of x is positive here. If we take x as 2, this is 2 which is positive, 1 minus 2 which is negative, altogether it is negative. So f of x is positive from the region 0 to 1. So x is an element of 0 to 1. Now look at the function carefully. Inside the square root it is a rational function. Therefore, denominator cannot be equal to 0. 1 minus x cannot be equal to 0 or x cannot be equal to 1. Therefore, what is the domain? Therefore, domain of the function is 0 to 1 open interval, not closed interval. Hope it is clear to you now. Let us discuss some more different types of questions. Now look at these questions. F of x is equal to root over x plus 2 plus root over x minus 2. We have to find out the domain. F of x is equal to root over x plus 2 upon root over 4 minus x square. How to find out the domain of such type of functions? In order to find out the domain of such functions, means if the function is of the form f of x is equal to f of x plus or minus g of x, or f of x is equal to f of x into g of x, or f of x is equal to f of x upon g of x. In all the three cases, domain is nothing but the intersection of domain of fx and domain of gx. Suppose domain of fx is represented by d1 and domain of g of x is represented by d2, then domain of f of x is nothing but d1 intersection d2. d1 intersection d2. If f of x is f of x plus g of x plus or minus g of x, f of x is f of x into g of x, f of x is equal to f of x by g of x. In all the cases, domain is nothing but d1 intersection d2. Now look at the first question. F of x is equal to root over x plus 2 plus root over x minus 2. That means it is of the form f of x plus g of x. We have to find out the domains independently first, then find the intersection. Means small f of x, take question number 1, take small f of x as root over x plus 2. Since it is a square root function, in order to find out the domain, take the expression inside the square root greater than or equal to 0, that is x greater than or equal to minus 2. So domain of small f of x is nothing but minus 2 to infinity. All of you know how to calculate this. Now calculate the second one. G of x is equal to root over x minus 2. We know how to calculate it. X minus 2 greater than or equal to 0. X greater than or equal to 2. That means domain of g of x is nothing but 2 to infinity. Now what about the domain of capital F of x? It is nothing but d1 intersection d2. What is d1 intersection d2? Now this is 0 minus 2, this is plus 2 minus infinity plus infinity. d1 is minus 2 to infinity and d2 is 2 to infinity. Now what is their intersection? The region common to both. The region common to both. What is that? 2 to infinity. So what is the domain of f of x? Domain of f of x is nothing but d1 intersection d2, which is nothing but 2 to infinity. Very easy. Okay, find out the domains independently and find their intersection. We will get the domain. Now look at question number 2. Again, this is of the form f of x upon g of x. What is f of x? F of x is equal to root over x plus 2. X plus 2 greater than or equal to 0. In order to find the domain, x greater than or equal to minus 2. So domain of f of x is nothing but minus 2 to infinity. Now what about the domain of g of x? Root over 4 minus x square. 4 minus x square is greater than or equal to 0 or greater than 0. What is the condition? Since it is in the denominator, the condition is only greater than 0. We have to consider both the conditions. So 4 minus x square is only greater than 0. Okay. Now, this is a square minus b square form, 2 minus x into 2 plus x greater than 0. We have to find out the region where it is positive, minus 2 plus infinity minus infinity. If we put x as 0, it becomes positive into positive, which is equal to positive. Here it is positive, here and here it is negative. So what is d2? d2 is nothing but open interval minus 2 to 2. Now we have to find out the intersection for domain of f of x. Domain of f of x is nothing but d1 intersection d2. What is d1? Minus 2 to infinity. What is d1? d1 is minus 2 to infinity. Is minus 2 to infinity. And what is d2? It is minus 2 to plus 2. Minus 2 to plus 2. So what is the region common to both? It is open interval minus 2 to plus 2. So what is the domain of f of x? It is nothing but minus 2 to plus 2 open interval. Is it clear? Hope the concept of domain is clear to you now. Thank you for watching my video. I will be back with more videos. Till then, bye.